Hey guys, in this lesson we are going to be studying the reactions involving acids and bases, specifically those of acids with metals and acids with bases, or neutralization reactions. And we'll finish up with a discussion of the different types of acids and bases, and additionally their salts. I want you to start your classwork page today with the homework listed here, and follow it up with our aim today, which is what kinds of reactions do acids and bases experience. Now, of course, there's a quiz associated with this lesson, so make sure that you study for it. It's the one where we're looking at the properties of acids and bases, and it's based on a table that you saw in lecture yesterday. All right, so reactions involving acids and bases. Acids and bases are an important part of chemistry because they are so reactive. Acids can react with bases. They can react with other compounds as well. And the products that you see on this page that are common acids and common bases that we use in our houses all the time, I would like to point out that bases are usually cleaning products and acids are usually for cooking. So let's look at our first reaction involving acids and bases, and this one is the reaction between acids and metals. And the acid that we're looking at here is hydrochloric acid, and our metal in this example is sodium. So when we predict whether or not sodium will react with hydrochloric acid, we can always use table J. It's called an activity series. It's on your reference table, and the really useful thing about table J is highlighted here. It says any given metal on this table could replace anything below it in either a single replacement or a double replacement reaction. So here's how to use it. Let's look at sodium, and we'll find it on table J and highlight it. I found sodium here. It's relatively high up on the table, which means that it can replace anything in this region. It can't replace any of these, it cannot, but it can replace any of these. And if you're looking really carefully, you'll find that hydrogen is down here among the elements that sodium could replace. So it is possible that sodium can replace hydrogen. So what does that look like? If sodium replaces hydrogen in the hydrochloric acid molecules, then that means that sodium would be bonded to chlorine rather than hydrogen. And in this case, we would have two of those ionic substances, NaCl, NaCl, to get rid of both the sodiums and both the Cls. And of course, we would have two hydrogens left over that had been sort of kicked out of their molecules and are not being used. They would bond together to make hydrogen gas. And of course, the NaCl that we were looking at earlier is salt. In this case, it's table salt. But this is the basic structure for any reaction involving acids and metals. You've got an acid like hydrochloric, a metal such as sodium. It's always going to produce salt and hydrogen. So I'm going to highlight the parts of that you must memorize. So you must memorize acids with metals produce salts and hydrogen gas. That is absolutely necessary to know for the regions. Acids plus metals yield salts and hydrogen gas. And before I move away from this slide, there is just a small tidbit that I want you to carry in your back pocket, which is that there are some nonmetals on this table as well. They're right here on the right-hand side. You cannot compare metals and nonmetals directly, but you can compare these four nonmetals. And just the same way that I use table J to predict single and double replacement reactions, for metals, you can also use it for nonmetals. So just know that fluorine would be able to replace chlorine in a compound. Chlorine could replace bromine, and bromine could replace iodine, but those are the only options. Iodine cannot replace bromine, bromine cannot replace chlorine, iodine cannot replace fluorine, and so on. Now, the other type of reaction that you need to know, like the back of your hand, is called a neutralization reaction. A neutralization reaction is a reaction involving an acid and a base, such as this base, NaOH, sodium hydroxide, and this acid, HCl, hydrochloric acid. But what do they produce when they react? I can reveal that to you relatively easily. So the Na and the Cl are the two parts of each of these molecules that sort of don't matter. Like what I mean is, in a base, the thing that they almost always have in common is that they contain hydroxide, or OH. In an acid, they almost always have the H in common. So that leaves the sodium and the Cl as sort of the odd men out. And of course, those are going to be the two that end up bonding to each other out of necessity. So there is a salt that's produced when the acid reacts with the base. Now, the part that I haven't dealt with yet is the OH, the hydroxide, which is the important part of the base, and the H, hydrogen, the important part of the acid. So when the OH bonds to an H, you get an HOH, which of course we would just call water. So let me highlight the part that you have to memorize, which is that when base reacts with acid, you get salt and water. And this is the basics of a neutralization reaction. Base plus acid yields salt and water. All right, now just to make this lesson a little bit harder, we're going to rewrite this equation, the sodium hydroxide, the hydrochloric acid, the NaCl, and the HOH, in its ionic form, keeping note that acids and bases and other ions dissociate in water. Follow along. So to start us out, I'm just writing in NaOH plus HCl is going to yield, in this case, NaCl plus H2O. But this isn't the ionic form. We're going to just really acknowledge that since there's water present in this reaction, that all of these three guys would dissociate into their ions. So I'll do those step by step. The NaOH is going to dissociate into a sodium ion and a hydroxide ion. The HCl is going to dissociate into a hydrogen ion and a chloride ion. And on the other side of the reaction, we're going to be looking at the sodium chloride, which will dissociate into a sodium ion and a chloride ion. But we've also got the water, which is not ionic and won't dissociate to any large degree. So I'm first going to highlight in black, or gray, I suppose, the ions that appear on both sides of the reaction in the exact same form. Sodium ions is the first one I would like to point out. On the left and the right, it appears in the same form, indicating that nothing has happened to it. It's the same as it was, and it really isn't taking part in the reaction. You might be able to find the next one, which is the chloride ion. It has the exact same appearance on the left and the right, Cl minus aqueous in both cases. So what's left over is the basis for any neutralization reaction. What you've got at the heart of any one of these reactions is an acid ion, or the hydrogen ion, reacting with a base ion, or the hydroxide ion, to produce water in every case. So I'm going to rewrite that now in its most basic form. And there it is. Before I move to the next slide, just know that I introduced a vocabulary word here, spectator ions. Spectator ions are the ones that are highlighted in gray, the ones that have the same appearance on the left and the right and don't take place in the reaction. All right, there are different types of acids, bases, and salts. We have these things called monoprotic, diprotic, and triprotic acids. The prot is referring to the hydrogens involved in the acid, and the Greek root is telling us how many there are. So monoprotic means one hydrogen, diprotic means two hydrogens, triprotic means three hydrogens. We have a similar idea for bases. When you see hydroxy, it's referring to the OH. So again, hydroxy is the OH, but monohydroxy means two OHs, it means one OH, so NaOH is here, and dihydroxy means two OHs, so this 2 subscript outside the OH means there's 2 hydroxides. All right, what type of reaction involving acids and bases produces salt? Well, acids can react with metals to produce salt and hydrogen, but that's not actually acids and bases, that's just acid and metal. So the only answer that makes sense for an acid and a base that produces salt is going to be a neutralization reaction. So I have a few examples of that kind of reaction here, the neutralization reaction, acid plus base yielding water and salt. And what we're going to do is we're going to fill in the missing species just using logic. So basically, if you take a look at this reaction, we have sulfuric and acid, and we have potassium hydroxide as the base. It's producing water. And the ions that are not represented in the water molecule are the ones that are going to be in the salt. I'll highlight them. Basically, we're not seeing the sulfate and we're not seeing the potassium when you look over here in the water. So that means that the molecule or the compound of salt is going to contain both the potassium and the sulfate. With respect to the charges having to add up to 0, the formula is going to be K2SO4. Sulfate has a -2 charge and potassium is +1, so you'll need 2 potassiums. Let's use that same strategy in the next question. We have water and we have calcium carbonate. Now the calcium is here in the base. The carbonate is what's missing. So we need to have an acid that involves the carbonate ion. Let's check table K. Table K does have an acid that involves the carbonate ion. It's H2CO3 and it's called carbonic acid. So I'll write that in now. Same strategy for the last question. We have water shown already, and we have sodium phosphate as the salt. Now the phosphate is here in the acid. We just need to figure out where the sodium is coming from. So let's check table K for a base that involves sodium. Excuse me, table L. So I was just looking for a base that involves sodium and I found it. It's called sodium hydroxide. So I'll write that in here. So last thing on this slide, what is a salt? A salt is just an ionic compound that results from the reaction between an acid and a base. And with that, we've reached the pair-up. So please copy down these pair-up questions and these summary questions before class begins. And thanks for watching.